sketching the absolute value graphs, our graph is given to us as y equals to a times the absolute of x minus p plus q. This is the standard form of any absolute value graph. In our example, we're given that y equals to 2 times x plus 3 minus 1. So we're going to sketch the graph. So the first thing we're going to identify is the shape of this graph. And having a look at the equation, I see that a equals to 2. Since a is greater than 0, I now know that that is the shape of my graph. The next point I want to find is the salient point, and the salient point has the coordinate PQ. To find the value of P, you're going to let the expression between the absolute sign equal to 0. So we're going to let x plus 3, we equate it to 0, and we solve for x, and we see that x equals to negative 3. So the salient point has an x coordinate at negative 3, and this is the value of P. Q, you get directly from your graph, and the value of Q is negative 1. So you write down negative 1. Let's just cast our eye back to the equation. So we see that P is negative 3 and Q is negative 1. Let's just look at the shifts. So if my graph is x plus 3 as I have here, that means that the graph of y equals to the absolute of x has shifted 3 units to the left, and my q unit is negative 1. The graph is then shifted 1 unit down. So the next point I'm going to find is the y-intercept, and to find the y-intercept, I let x equal to 0 in my equation. So I have y equals to 2 times the absolute of 0 plus 3 minus 1. So the absolute of 3 is 3. 3 multiplied by 2 gives me 6. Subtract 1 gives me 5. So therefore I have a y-intercept at x equals to 0 and y equals to 5. The next thing we're going to do is find the equations of the two arms, and then we find the x-intercepts. But you could directly find the x-intercepts by letting y equal to 0 and then solving the equation. So I'm going to find the equations of the two arms using the definition of an absolute value. So the definition says that the absolute value of x will equal to x if x is positive, so that will equal to x if x is greater than or equal to 0, and equals to minus x if x is less than 0. So I have the positive, so the positive arm of my graph will be y equals to 2 times x plus 3 minus 1. And if I simplify this equation, I get y equals to 2x plus 5. The other arm is found with the negative of the absolute. So I'm going to write it as y equals to minus 2 times x plus 3, or you could have said minus x minus 3 minus 1. Be careful with the signs. So this is going to give me minus 2x minus 7. So these are the two arms of the graph that's going to be formed. Right, so now I'm ready to find the x-intercept. So looking at the first arm of my graph, for me to find my x-intercept, I let y equal to 0. So let me just write down that I'm finding the x-intercepts. So I go 0 equals to 2x plus 5. And then when I solve for x, I see that x equals to minus 5 over 2, or 2.5. So the coordinate of my first x-intercept is minus 5 over 2 and 0. I repeat the process with the second arm of my graph. So I let y equal to 0. So 0 is going to be minus 2x minus 7. Here I have x equals to minus 7 over 2. or negative 3.5. So therefore I have another x-intercept at negative 3.5, but I'm going to write it as negative 7 over 2 and 0. So we have found a number of points and we are now ready to plot the graph. So the first point that I am going to draw is the salient point. So remember, we found the salient point at x equals to negative 3 and y equals to negative 1. So that's my salient point. The other point that I found was my y-intercept, and I know that my y-intercept was at x equals to 0 and y equals to 5. Above, I see the two x-intercepts. I have an x-intercept at x equals to negative 2.5 and y equals to 0. So that's negative 1, negative 2.5 and y equals to 0 is there. I have another x-intercept at negative 3.5 and at 0. So x is negative 3.5 and y is 0. So I have actually 4 points to draw the graph. Remember, our axis of symmetry is passing through x equals to negative 3. I'm just writing down the coordinates of the salient point. And now I'm going to draw the arms of the graph. Right, so this is the graph. So we got the graph of y equals to 2 times the absolute of x plus 3 minus 1. And remember, always label your salient point, label your intercepts, so the x-intercepts and the y-intercepts. So let me start with the y-intercept. When x is 0, y is positive 5. And then we're going to label the x-intercept. This one is going to be minus 5 over 2 and 0. And the next intercept here is going to be minus 7 over 2 and 0. Before we move on to the next example, you could have even have written down the equations of each of the arms of the graph. So remember, when x is greater than or equal to negative 3, then the arm of the graph was y equals to 2x plus 5. And when x was less than negative 3, this arm of the graph is minus 2x minus 7. It's not necessary to do so, but you can. So in example 2, we have y equals to minus 2 times the absolute of 2x minus 3 plus 1. So the shape of the graph is dictated by the value of a, and in this situation a has a value of negative 2, so I know that this graph has this shape here. The next point that I immediately find is the salient point. Remember, the coordinates of your salient point are P and Q. So to find P, we let the expression between the absolute value signs equal to 0. So I got 2x minus 3 equals to 0. And solving for x, I get x equals to minus 3. Sorry, it's positive 3 over 2. So I have a salient point at 3 over 2. That is the x-coordinate of the salient point. The y-coordinate of my salient point is the value of q. And in the graph above, it is 1. Once again, we're going to find our y-intercept, so we let x equal to 0. So we got y equals to minus 2, the absolute of 2 times 0, minus 3, plus 1. So this gives me minus 2. So I have the absolute of negative 3 plus 1. The absolute of negative 3 is positive 3. So this gives me positive 3 multiplied by negative 2 gives me negative 6 plus 1 gives me negative 5. So I have a y-intercept at x equals to 0 and y equals to negative 5. We're ready to find the x-intercept. So to find the x-intercept, you're going to let y equal to 0. So you got 0 equals to negative 2. So 0 equals to minus 2 times the absolute of 2x minus 3 plus 1. So our first equation is going to be 0 equals to minus 2 times the positive of the absolute, so it's 2x minus 3 plus 1. That is if, remember our restriction, you're going to let 2x minus 3 equals to 0, which we have done finding the salient point. So you get x equals to 3 over 2. And this is only true if x is greater than or equal to 3 over 2. So I simplify this, I get minus 4x plus 6 plus 1. So it gives me minus 4x plus 7. And if I solve for x, I see that x equals to 7 over 4. So I have an x-intercept at x equals to 7 over 4 and it's 0. I have another x-intercept when the value between my absolute sign is negative according to my definition. So I am going to write it as 0 equals to minus, and then I have minus 2 times 2x minus 3 plus 1. What you could have done also is rewrite it as minus 2 times minus 2x plus 3, because if you multiply that by a negative, because you're looking at the negative side, remember we're looking at x less than 3 over 2 now, then your signs will change. So we got 0 equals to 2 times 2x minus 3 plus 1. So 0 equals to 4x minus 5. So therefore, I have an intercept at 5 over 4 and at 0. Let's plot these points on the Cartesian plane. So I have just scrolled up to remind ourselves of the points that we've plotted. Remember, we have the salient point at x equals to 3 over 2 and 1. We have a y-intercept at x equals to 0 and negative 5. Then we have our two x-intercepts at 7 over 4 and 0 and 5 over 4 and 0. So the first point that I'm going to plot is the salient point once again. And remember, the salient point x was 1.5 and y was 1. So x is 1.5 and y was 1. So that is my salient point there. I'm going to just write it down. 3 over 2 and 1. Now, so my x-intercepts are very close to my salient point, so the arms of this graph is really very narrow, because if you look at your first salient point, your first intercept, this one equals to 1 3/4, so it's 1,75 and 0, and the next one is 1,25 and 0. So I have 1.5 here. The one x-intercept will be 1,25 and 0, and the other one will be 1,75 and 0. So the x-intercepts are very, very close to your salient point with this graph. Sometimes when this happens, rather just choose a random point. Maybe substitute x equals to 1 and to get a better coordinate, or substitute x equals to, say, 2 to get a better coordinate. But these are the points that I've plotted, so I'm going to now draw the graph. So this is the graph, and once again you can put arrowheads at the end of the graph to indicate that the graph continues. but we're going to label our cardinal points. So when x is 0, y is 5 is an important point there. It's your y-intercept. I've labeled the salient point. I'm going to label that x-intercept. That x-intercept is 7 over 4 and 0. And the next one is 5 over 4 and 0. So this is the graph.